Right, in questions 10 and 11, we're going to write recurring decimals as rational numbers. So here we're asked to evaluate this. Now we've got some Turkish decimal notation. So 0.6 repeater is going to be 2/3. We should know 1/3 is 0.3 repeating, so 2/3 0.6 repeating. And that is being divided by 0.3. Well, that's in the tenths column, so we know the denominator has to be 10. And we're going to subtract. This is 2, and 2 repeating, well, any repeating digit is going to have the denominator of 9. So that's our setup here. We've written those decimals as rational numbers, and so now it's just a matter of subtraction. But before we subtract, we should simplify this first fraction. We look at the denominators here. I'm making this look a bit messy. We've got 3 and 10. So we'll find a common multiple there. So we're going to multiply by 1, but we're going to multiply the numerator by 30 and the denominator by 30. So we're not changing the number at all, changing the fraction at all. We're just making the denominators cancel out. So in the numerator, if we just look at this section here, we'll see that the 30 will cancel here, and so we're actually multiplying by 10. So let's undo that bit there. So this here is going to be equal to, in the numerator, 20, and in the denominator now, let's look here. We're saying 30. Well, when we divide that by 10, we're going to be multiplying that by 3. So the denominator there, we should have 3 times 3 will be 9. So we've simplified that fraction there by multiplying using the denominators there. And now we're going to write this as the second part here. We're going to write this as one fraction. So the denominator will be 9. And to work out the numerator, well, there's 2 is 18 over 9, plus the 2 there will give us 20. And, well, what's going to happen if we subtract the same thing from itself? The answer is going to be 0. So, question 11 now. We've got m equal to 2.07 repeating. So let's write this as a rational number too. So we've got 2. And to write the 0.7 repeating, we should say all of the decimal places in the numerator minus the non-repeating digits. Let's just write it in anyway, even though it's the same thing. And divided by 9, because there's one repeating digit and one non-repeating digit. We're going to put a 0 there. So that's the first part, minus 1.9. So we've got 1 and the 9 divided by the 9. Well, actually, that's just equal to 1, isn't it? So we'll be able to simplify that pretty quickly. So we've got m here is going to be 2 and 7 over 90 minus 2, and we can see that that's just going to be 7 over 90. So let's look at n now. Let's do a little different colour for n. 1.6, well, 0.6 we learned was 2 over 3, 2/3, a nice common decimal, repeating decimal, plus 1, and now we have some decimals here. We've got 19 is in the decimal places. We're going to subtract the non-repeating decimal, and in the denominator there's one repeating digit and one non-repeating digit. So if we look at this whole addition now, we've got 1 plus 1. I think we can agree that that's 2. Now to make this addition of fractions a little bit easier, let's find a common denominator. So the common denominator can be 90, and we're going to need to multiply this fraction here by 30 over 30, or multiplying by 1 to get to the equivalent fraction here. So the numerator would become 60, 2 times 30, and we're going to add 18, which is 19 minus 1. So all up we've got 2 and 78 over 90, and these numbers can be simplified. Although let's hold off on the simplification now, because we want to calculate n minus m, and we notice here that the denominators are the same, so that's a good thing. If the denominators are the same, it's going to be easy to combine them. I'm going to use the space above because I've run out of room here. So we're going to say n minus m is going to be equal to 2 and 78 over 90 just substituting for n, minus 7 over 90, and we should be able to see here relatively easily that it's going to be 2 and 71 over 90. And we can, if you want to rewrite this as a rational number, we would multiply 90 by 2. So if we're going to write the equivalent rational number over 90, we'd have 180 plus 71. And I'm just going to continue over here, which is equal to, what do we got, 251 divided by 90.